Okay, so trigonometric ratios 5.2. So last time I start talk about if I have like triangle like this is my triangle. It's has acute angle. If I have triangle like this, uh, this angle is, suppose it's my theta, called theta. This side is called the opposite of the theta. Opposite of the theta. This side is called the adjacent. And here is the hypotenuse of this theta, this angle. So first of all, we have to know, number one, the sine of this angle is equal the opposite over the hypotenuse. Second things we have to know, number two, the cosine of this angle is equal adjacent over the hypotenuse. Number three, the tan of the angle equal the opposite over adjacent edge. And also we should to know the reciprocal of each of this. So number four, the reciprocal of the sine is called the cosecant. Cosecant angle is equal 1 over sine of the angle, and this is equal the hypotenuse over the opposite. Number 5 is the secant, the reciprocal of the cosecant theta is the secant theta over, this is equal 1 over cosine angle, and this is equal hypotenuse over adjacent. And number 6, the last one, is the cotan of the angle, and this is equal 1 over tan of the angle, and this is equal adjacent over edge over opposite side. Here is the attendance for the student who asked. Here is the link again. Hold on. This is the link. Okay, so also we should know some specific, like some special values for some angles. Here, special values. So I'm going to share my screen for table. This table, we're going to use it a lot during this section, is a special values for some angles. Also, so I mean, like this table will be like attached with this note for this section. So here I'm going to share it. So this table, we should know how you see this table. Can you see this table?
Yes.
Yes, we can.
Yes, okay. So the first degree is, this is in degree, this column is in degree, and this column it's in the radian. So the 0 in degree, as we learned last time, how we can convert the degree to radian. So we have to multiply the angle by what? To convert from degree to radian, we have to multiply the degree by, anyone can remind me? If you want to convert from degree to radian, we have to multiply the degree by pi over 180. The pi over 180. So the 0, when you convert it from degree to radian, is will stay 0. The 30 degree, to convert it to the radian, you have to multiply this by pi over 180, so you will get pi over 6. And the same things for 45, it's pi over 4. The 60 is pi over 3. The 90 degree is pi over 2. So you should know the sign of the 0 is 0, and the cosine for the 0 is 1, and the tan is the sine over cosine 0. And the same things for the other. Here the cosecant for the angle does not have. Why? Because the reciprocal of the 0 is 1 over 0. So 1 over 0 is undefined. 1 over 0 is undefined. That's why we doesn't have a cosecant for the degree for the theta equals 0. Okay? So 1 over 0 is undefined. That's why here we doesn't have a value. The same things for cotan. Cotan is 1 over 10, and 1 over 10 is 1 over 0. So it's not defined. That's why we doesn't have a value here. Okay? So here the sign for 30 is 1/2. You're supposed to remember this. Also the cosine for the 30 is by the square root of 3 over 2. And the tan is sine over cosine is square root of 3 over 3, or you can say 1 over square root of 3. The same things. The same things for cosecant. It's the reciprocal for the reciprocal of sine. Secant, it's the reciprocal of the cosine. The cotan is the reciprocal of the tan. And for the angle 45 is the square root of 2 over 2, and the cosine is the square root of 2 over 2. The tan is 1 because the sine over cosine is equal tan, is 1. Same things for the degree 60, square root of 3 over 2. The cosine is 1/2, and the tan is the square root of 3. The same things here. It's the reciprocal for the ratios. For the 90, the sine is 1, the cosine is 0, the tan is sine over cosine is 1 over 0. So 1 over 0 is undefined. That's why it doesn't have a value here. The tan does not have a value for the degree for the angle theory or for pi over 2. Same things here. Cosecant is 1 over sine is 1, and the secant is the reciprocal of cosine is 1 over 0, so it's undefined again. 1 over 0 is undefined. The cotan is 1 over 10, or you can say the cotan is cosine over sine is 0 over 1. 0 over 1. So 0 over 1 is 0. Look, the cotan here has a value 0, but the tan does not have any value. And you know the cotan is the reciprocal of the tan, so the tan doesn't have a value, but the cotan doesn't have a value, is 0. Okay? Okay. Any question for this table? So you have to memorize all these angles. You have to memorize the sine, cosine, tan. This is the important things for all angles. And from this, you can know, or you can derive the cosecant and the secant and the cotan. Any question before we move back to the whiteboard? What's your question, Omar? Why is the cosine of 0, 1? This is your question? Why the cosine of 0 is 1? I can explain this, but you don't have to. Just you have to memorize all this table. I can explain why is 1, but you don't have to. Just you have to memorize the cosine of the 0 is 1. That's it. If you need to know this, just you can take calculus, pre-calculus or calculus 1. Or if you need it, I can explain it. Just email me and I will explain it for you. Okay? But right now, you should know the cosine of the 0 is 1. That's it. The sine is for the 0 is 0. The tan is 0. And you can derivative of the derive this cosecant, secant, cotan by using the sign, because the cosecant is the reciprocal for the sine, the secant is the reciprocal of the cosine, and the cotan the same things. But you should to focus for the 90 degree, because the 90 degree, the cotan has a value 0, but the tan does not have a value. Yes, what's your question? What do the dashes? Dashes? What is that? Undefined dashes.
By dashes, I meant like you see where it says CSC 0, and then you go to the other chart, it says 0 in degrees.
This is what you mean.
Yeah.
This is mean. Okay, undefined does not have value. This is mean here. The dash here, and this one means undefined, does not have a value. We don't have any value. So here, what doesn't have a value? This means the cosecant for the degree for the angle 0 does not have value. So you can say undefined or does not have a value. Okay. You're welcome. Any other question? Okay. So now let's go back here. So the special values, like I mean like the table. What is the like the table for the angles? Okay. Yes, we have to need to know the cosine of the 0 equal 1. Yes. And the sine of the 0 equal 0. Okay. Now we have some application for this thing. So the application is very important. It's not so that much hard, it's easy. The application of right triangle. Okay, so some application, we're going to use it for right triangles. Okay. Yes, here you go. Kristen, Jennifer. So what is the meaning of application of trigonometry of right triangles? This is mean we have like, okay, what, Jennifer, you finish? What about the other, Kristen? Okay, so this is mean like any triangle, any right triangle has 3 sides. Here is the right triangle. This right triangle has 3 sides, and in the same things has 3 angles. So this is mean the application of trigonometry of right triangle. We should to know the measure of this 3 angles, and also we should to know the length of this 3 sides. So if I give you, for example, here question number 1 or example number 1. So example number 1, the question is solve trigonometry. Solve triangle ABC. This triangle has name ABC, the name of the angles shown in the picture. So this is my triangle. It has a name A. This is A. Here is B. This is C. First of all, this is the in front side of A capital angle called A small. This is the small c here. And this is the small b, but it's called the hypotenuse. So suppose this is my angle. This is my angle. And the hypotenuse has a length 12 unit. My question is find the value for A and the value for C if this angle equal 30 degree, like this. If this angle is 30 degree, find the value of A and the value of this for the small a and the small c. Okay, so by using the table like I showed you 1 minute ago, so I know, and by using the trigonometric or the trigonometry ratios, so I know what is the mean of the sine. I know the formula of first one, the sine function, right? The sine of the angle 30, what is that equal? The sine of 30 equal what? The sine of this angle equal what?
Opposite of a hypotenuse.
Exactly, the opposite over the hypotenuse. The opposite side here is
A over 12.
A over 12. A over 12. And in the same times, I know the sine, the value of the sine 30. So this is mean A, the unknown value, I can't find it. So what I should to know now, what should I should to do? I have to multiply both sides by what? By 12. So multiply this side by 12 and multiply this side by 12. So you will get what? 12 sine of 30 equal what? A. Why? Because the 12 with the 12, they cancel out. Things will left here. Sine of 30 times 12 equal A. Now, what is the value of sine of 30? What's the value of sine of 30 by using the table? One half, exactly. So the sine of 30 by using the table before is 1/2. So the value for A equal 12 times 1 over 2. This is equal 12 over 2. And this is equal what? 6. So the value of A is 6. The value of A is 6. So this is equal 6. Now for C, how can I find the value for C? Here, C. What function I should to use? Yes.
But you can do opposite. Opposite of adjacent.
Adjacent over what?
Opposite over adjacent. So it's 6 over C.
6 over C. I mean, which function would you like to use here from the trigonometry ratios? Sine, cosine, tan, cosecant, secant, cotan. So the hypotenuse is given, right? But the adjacent is not given, and the angle is given. What function is the best one you should use?
Cosine?
Cosine function, correct. Cosine equal the adjacent over the hypotenuse. So let's using the cosine function. Cosine of the angle theory, the cosine of this angle equals C from here. So here is the value of C over the hypotenuse. Hypotenuse is 12. Now we should to multiply both sides by 12. If we multiply both sides by 12, this by 12, so 12 with this 12, they can cancel out. So now I get the value for C only. So C equal cosine of 30 times 12. Now, what's the cosine of 30 by using the table? You should to memorize this table. What's the cosine of 30?
The square root of 3 over 2.
Yes, square root of 3 over 2, correct. Square root of 3 over 2 times 12. And this is equal, we can here cancel the 2 with the 12, we will get 6. And 6 times the square root of 3 is 6 square root of 3. And so the value for C here is equal 6 square root of 3. This is what you should know, application. Okay, any question? Okay, so my second example, example number 2. Suppose I have a tree. This tree makes a shadow 532 feet long. So the question is, find the height of the tree if the angle of the elevation of the sun is 30 degrees. Okay. So suppose I have a tree like this. Here's my tree. This is my tree. A tree makes a shadow. So the shadow is like something like this here. This is the shadow for the tree. So the length of this shadow is 532 feet. So 532 feet. The shadow makes by the sun. So here is my sun. So the sun ray, it's look like this. Okay, this is the sun ray. And the angle here, the elevation of the sun has 30 degrees. This is mean this angle here is 30 degrees. The question is, find the length of this sun. So the question is find the length of this sum. The question is find the length of this sum for this tree. This is my tree, and this is the shadow. This is my sun. Make a degree, make an angle 30 degree. Okay, so how can I find which function I should to use to find the length of this tree? Suppose my length of this tree is x. How can I find the value of this x? What function I should to use?
Use tan.
Tan. Yes, correct. Like because the tan equal what? Tan of the
Opposite
angle.
over adjacent.
Exactly. The tan of this angle, the tan of 30 equal the opposite of adjacent. The tan of the 30, the tan of this angle equal the opposite by using here this formula. The tan equal the opposite over the adjacent. The opposite over the adjacent. So the adjacent is given. This is given. And not given, it's unknown. So is the best things we have to use is the tan of the angle. The tan of the 30 equal the opposite x over 532. So I can do a cross multiply or multiply both sides by what? By 532. So let's doing a cross multiply. This is over 1 actually. So x times 1 is x equal tan of 30, tan of 30 times or multiply by 532 fit. Now my question is, what is the tan of this angle? The tan of 30. This is from the table. You should memorize the table. Exactly, Michael. Would be tan of 30 equal x over 532. Now my question is, what is the tan of 30?
Square root of 3 over 3.
Yes, square root of 3 over 3. Multiply by what? 532. We can simplify this, right? Let me check. We can simplify. I think we cannot. So we can keep the answer as 532 multiplied by square root of 3 over 3, like this. Because the calculator is not allowed during the exam. So the length of the tree is 532 multiplied by the square root of 3 over 3. This is the value of x. You can leave it like this, but if there is some simplifying, you have to do it. But 532 does not divide by 3. 532 cannot divide by 3. So we should to leave it like this. Okay? But if this number can divide by 3, you have to simplify it. It's better to simplify it. You will not lose a point, but it's better to simplify it. Okay, any question for this example? So tomorrow, I mean like Wednesday, maybe you can see a question like this. Find the length of a tree. If I give you like the shadow like this and the angle like this. Maybe I will give you the angle 60, not 30, or like the angle is 45, for example. So you should to know how we can find the length of the length of the tree or the height of the tree. Any question? Okay, this is what you should to know about this section. So we finished this section. Now let's go to the 5.3, section 5.3. 5.3. It's called trigonometric functions of angles. So the difference between this section and the previous section, so in the previous section, we was talking about the trigonometric ratios. I mean, like for angles, I mean, like for acute angles. I mean, for acute angles, any angle less than 90. Like for example, 30, 60, 45. All of these angles are acute angles. Now we're going to learn for like any angles, what's the value for the ratios function for any angles, more than 90 and less than 90, okay? So first of all, we have to know, I'm going to graph some angles to show you here. Yes, Amr, do you have a question? You're raising your hand. Okay, so first of all, trigonometric functions. This section talking about the trigonometric of angles. So first of all, we have to know how to graph, or how is the angles look like. So if my angle, so here is like, as we learned before, the angles should be in the standard position. I mean, like, should be the standard position, meaning the initial side must be in the positive x-axis, and the initial side anywhere else. The vertex also must be on the 0, 0. So the first angle, suppose it's the 0 angle. So the 0 angle should be something like this. This is the 0 angle. Again, the red one is my initial side, and the green one is my terminal side. And the vertex is 0, 0. Here we have to know the angle measure is 0. So 0, 0 degree. This has 0 degree. For the second one, okay, so here is my initial side again. And this is my terminal side, making an angle measure 90 degree. So this is my terminal side. The angle here in the second one is 90 degree. This angle here is a 90 degree. The 90 degree, if you want to change it to convert it to the radian, this is equal pi over 2 radian. Third angle you should to know is, as I said, all of them, the initial side is the positive x-axis. Here's the positive x-axis for all of them. Now for the third one, if the angle is 180, this is the angle 180. This is the angle 270. So for this one, this is 180 degree, and the 180 degree, if you want to convert it to the radian, this is equal pi. And the same things for this here. This is 270 degree, and this is equal 3 pi equal 3 pi over 2 radian. And the last one is the same as the 0, but we can also so here is the last one is the same as the 0 degree, or it can be 360 degree. So the 0 degree is staying in the same things, but here we have to turn around like this. So this is 360 degree, and this is equal 2 pi in the radian. But here it cannot turn around, so it will stay in the same point. So this is the same as 0 degree, and the same is the 0 radian. Okay, any question for this graphs, for this angles? Also, we should to know the acute angles, like the 30, the angles of 30, 60, 30, 45, and also 60. So all of them has angle in the positive, in the standard position. This is my positive x-axis, initial side, positive x-axis. And the first one is 30 degrees, so it should be like something like this. This is the 30, this is 45, and here is 60. So this angle is 30 degree and is equal pi over 6 radian. This is 45 degree equal pi over 4 radian, and this angle is 60 degree equal pi over 3 radian. Okay. Any question for this angles? Here's number 1, 2, 3, 4, and this is 5. This is 6, 7, and 8. Any question for this angle? Just you have to know how is the graph, or how we can graph like the degree, the angle 45, for example, or 60 or 30, or any one of this from 1 to 5. Okay. Now, trigonometric function. This is the important things. So trigonometric function, so this is mean I can find the value for any trigonometric ratio for any angle. It's not just for acute angle, any angle. So this is, suppose this is my x-axis here. Suppose my angle look like this. Okay. This is the Cartesian plane. So first of all, I'm going to graph like a small triangle. This is hypotenuse. Okay, opposite. This is my angle. So the value here, suppose the angle has a name. This is O, this is B, and this is Q. The value from O to Q has a value measure is X. And from B to Q has a value is Y. And from O to B has a value R. And the R, by using the Pythagorean theorem, equal the square root of X squared plus Y squared. Now I can define all the trigonometric functions by using this triangle. So I can define all trigonometric function of this angle. So first of all, the sine function, the sine of the angle theta. What is that equal? What is the sine of angle theta? This is just a review. What is the sine of angle theta?
Opposite over hypotenuse, so it's y over square
R.
root. Yes, y over
Yes,
r.
exactly. Y over R. So this is equal Y over R. The opposite over the hypotenuse is R. Or you can say the square root, such that R here does not equal 0. This is very important. This R has a length does not equal 0. Nice. Now number 2, cosine. What is the cosine of the angle theta? What is the cosine?
X over r. I mean, yes,
X over R.
r.
Exactly. And R again not equal 0. So the sine theta, also the reciprocal of the sine is the cosecant theta is equal R over what? Over Y.
Y.
Yes. Now for the cosine theta is equal the adjacent over the hypotenuse is R. So X over R and R not equal 0. The same things for the reciprocal for the cosine is the secant. Secant theta is equal R over X. Now the third function, I can define it as the tan function. Tan function. What is the tan equal?
Y over x.
Y over X, correct. Y over X. And the same things for the cotan of the angle, the cotan function. Now I said cotan function of the angle is the reciprocal is X over Y. Okay, any question for this? So I define the ratios as a function now. The sine, the cosine, and the tan function. The sine function, and this is the cosine function. So I define it as a function, not a ratios. And the last one is the tan function. Any question for these functions? Sine function, cosine function, tan function, and also the reciprocals. you should to know for all this function, here is the initial side, it's in the positive x-axis. Also, this is called the terminal side, and you should to know the angle is in the standard position. Okay, all this angle, it's in the standard position. I mean, in the standard position, the initial side in the positive x-axis. For all this, it's the positive x-axis, and the terminal side, it's in the first quadrant. And you should to know the vertex is the 0, 0. Okay, so this is, you should to know here, all of them, it's in the standard position. That's why I did not give any sign. I mean, sign positive or negative for these functions. Any function has a positive or negative, but all of them I give the positive. Why? Because the initial side, it's in the positive x-axis, and the terminal side, it's in the first quadrant, and the first quadrant, the y value or the x value is positive. So now I'm going to learn how we can evaluate any trigonometric function at any angle by using some steps. This is the very important. Evaluate metric functions at any angle. It's not that much hard here. Evaluate trigonometric function at any value is not that much hard. You have just to follow some steps. So the first one, you should to know what is the sign of the trigonometric functions. I mean, for the sign is positive or negative. Second step, you have to find the reference angle. Okay, so for the first one, I'm going to explain what is the meaning of the sign of the trigonometric function. For number one, the sign of the trigonometric function, the function is not always positive. So here the sign of trigonometric function. This is mean the function is not always positive, or in the same things is not negative all the time. So here's my Cartesian plane. You should to know in the first quadrant, all function is positive. I mean, all trigonometric function is positive. The sine function, the cosine, and the tan. And the same things for the reciprocal. All the function here are positive, all of them. All of them, I mean the sine, the cosine, the tan. All the function are positive in the first quadrant. If the angle it's in the first quadrant, so the trigonometric functions, all of them positive. Here the sine, cosine, and the tan positive. Why? You should know that because the positive x-axis and the positive y-axis, both of them are positive. That's why the sine and the cosine and the tan, all of them positive. For the second quadrant, if my angle something like this in the second quadrant. So in the second quadrant, you should to know the only function is positive is the sine. the only function is positive for the second quadrant is the sine function. So the sine is the only function is positive in the second quadrant. If my angle it's in the second quadrant, the sine function is the only one is positive for the second. Now for the third one is the tan. You should to know if my angle it's in the third quadrant, and like I said all the time, my initial side is in the positive x-axis and the angle it's in the third quadrant, the tan function is only positive. And for the last quadrant, the cosine function is the only function here is positive in the fourth quadrant. So from this, I can collect it in one word: all student take calculus. The first letter here, A, all student take calculus. This is just a way to help you to remember which function is positive in which quadrant. All student take calculus. Is it clear here?
Yes.
All student take calculus. All function here is positive. Sine function is positive. Tan function is positive. Cosine function is positive. This is about the sine here. Now the reference angle. Number 2, as you see here, the reference angle. I'm going to explain what is the meaning of the reference angle. Okay, number 2. Before I move, it's clear here. Which function is positive? Okay, second one. Reference angle. So the reference angle here, what is the meaning of reference angle? So I'm going to give the definition. What is the meaning of reference angle? The reference angle. Let theta, suppose my angle is theta, be my angle in the standard position. Standard position, what is the meaning of standard position? Anyone can remind me what is the meaning of standard position? The initial side, where is it? Where is my vertex?
X-axis.
Any x-axis? Or it's in the positive?
Positive.
Exactly, positive x-axis. And where is the vertex? At the
origin.
origin, exactly. So the standard position, so my angle, it is my initial side, it's in the positive x-axis, and the vertex at the origin, 0, 0. And this is my angle, for example, or this is my angle, or this is my angle, whatever is it. Okay, so my angle here, it's in the standard position. The reference angle, we call it as like this, like theta bar, is acute angle formed by the terminal side of theta and the x-axis. I mean for that, So first of all, suppose my angle, it is in the positive x-axis like this. All of them in the standard position. So all of them, the initial side, it is in the positive x-axis. All of them like this. And my angle, it is here. This is my angle here. Suppose my angle here. Suppose my angle is here. Suppose my angle is like this. So again, this is my angle, theta. This is my angle, theta. This is my angle, theta. And this is my angle, theta. Now, my reference angle here for the first one is acute angle formed by the terminal side. This is my terminal side of theta and the positive and the x-axis. So this is my x-axis. This is my x-axis. Okay. This is my x-axis. This is my x-axis here. And this is my terminal side, the green one. So the acute angle between the green one and the positive x-axis is this. So this is my reference angle. So my reference angle is the same as my original angle here in the first case. So my reference angle is the same as my original angle. Now for the second one, what is my reference angle? My reference angle is acute angle formed by the terminal side. The green one is my terminal side, and the positive x-axis, and the x-axis is not the positive, the x-axis. So this is my x-axis. This is my x-axis, and the acute angle between the terminal side and the x-axis is this. This is my acute angle. So this is my reference angle. Here my reference angle is this. This is my reference angle here. Now for the third one. Again, this is my x-axis, and this is my terminal side. The acute angle is this, from here to here. This one. From here to here. This is my reference angle. For the last one, here's my x-axis, and here is my terminal side. So the acute angle is this, from here to here. This is theta bar. Any question for the reference angle? So the reference angle for the first quadrant is the same as the original angle. For the second one is this. Third one is this. Fourth one is this. I'm going to give you a table. This table will help you a lot for all this section and the next section for the reference angle. So the angle in the first quadrant and the angle in the second quadrant and the angle in the third quadrant and the angle in the fourth quadrant, they have the same reference angle. So my angle, suppose my angle is pi over 3. And the angle in the second quadrant is 2 pi over 3. And here the angle is 4 pi over 3. And this angle is 5 pi over 3. All of these angles have the same reference angle. all of them have the same reference angle, this angle. The reference angle of all of them is the same, is pi over 3. So I'm going to give you a table for the angles. Just memorize this table. They will help you a lot to find the reference angle for anyone. Yes, I will go back for 1 second. This table will help you a lot to find the reference angle. Here you go, Jennifer. Have you finished? Okay, so pi over 3, it's a angle in the first quadrant. This angle, it's in the second quadrant. This one in the third quadrant. This angle, it's in the fourth quadrant. All of them, this one and this one and this one and this one, all of them have the same reference angle. It's pi over 3. Same things for the angle. By the way, pi over 3, it's 60 degree. This is 60 degree. Now the second one is, suppose my angle it's pi over 6. So this is 30 degree. This is in the first quadrant. The second, and pi over 6 is it's in the first quadrant. This angle 5 pi over 6, it's in the second quadrant. This angle 7 pi over 6, it's in the third quadrant. And this angle, it's 11 pi over 6, it's in the fourth quadrant. All of them have the same reference angle. It's pi over 6. And also you should know pi over 4, it's in the first quadrant, and 3 pi over 4, it's in the second quadrant. 5 pi over 4, it's in the third quadrant. And 7 pi over 4, it's in the fourth quadrant. All of them have the same reference angle, pi over 4. And you can check that by graphing like this. Do something like this. So my example now, after we find the reference angle and the sine, we can find the the trigonometric function for any angle. So my question is, find sine of the angle 7 pi over 6. So first of all, we should know two things. When you see something like that, if I bring a question like this in the exam, it's not hard. You have to know two things. Where is the position of this angle? In first, which quadrant? This is mean they give you the sign, positive or negative. Second things, you have to know what is the reference. So first of all, we're going to graph the Cartesian plane like this and put the angle. So 7 pi over 6, it is showing it's in the fourth quadrant. Why? Because the first quadrant is between 0 and pi over 2. Or if you want to convert it, this angle is pi over 2. If you want to convert it to over 6, you have to multiply both sides by 3. So it's 3 pi over 6. The first angle is not between 0 and 3 pi over 6. It's not in the first quadrant. And also it's not in the second quadrant, because the second quadrant, the angle here, it's pi. And the pi is actually pi over 1, and this is equal 6 pi over 6. So this angle, 7 pi over 6, is not in the second quadrant. Okay. Now 7 pi over 6, let me check. Is it in the third quadrant? The third quadrant here is finished at 3 pi over 2. And 3 pi over 2, if we want to make the denominator over 6, we have to multiply both sides by 3. This is 9 pi over 6. So 9 pi over 6 is greater than 7 pi over 6. So this is mean the 7 pi over 6 is in the third quadrant. It's not in the fourth. It's in the third quadrant. So actually, the angle should be like this. Here is the standard position, like I said before. Always the standard position in the first, in the positive x-axis, and the terminal side should be in the third quadrant, like this. So the angle is something like this. This is my angle. It's equal 7 pi over 6. First question. What is the sign of the sine function? Number one, what's the sign for the sine function in the third quadrant? What's the sign of the sine function? It's negative. Exactly, correct. Go back. The sign in the third question in the third quadrant here is negative. The only function is positive is the tan. The only function is positive is the tan function, and anything else is negative. So the sine function here is negative, and the cosine function here is negative. The tan function is here in the third quadrant is only positive. So the sign of the function is negative. Now, second step. What's the reference angle for 7 pi over 6? Go back to this table. Go back to this table. This table told you look to this table. This table told you you have to look in for pi over 7 pi over 6. 7 pi over 6 is here, this one. And it's look like in the third quadrant, like the table told you. This is correct. This is what we find. And the reference angle of this is pi over 6. The reference angle of 7 pi over 6 is pi over 6. So the reference angle So step number 2, the reference angle of the angle 7 pi over 6 is pi over 6. So now the question is so easy to find. So just you have to rewrite this in different way. So you're going to write sine of 7 pi over 6 equal minus the minus I get from the first step, sine. You see the sign here, negative. And then you have to write sine of the reference angle, pi over 6. Now you have to go back to the table I shared in the beginning of the class. What is the sine of pi over 6? What's the sine of pi over 6 from the table in the beginning of the class?
Is it 30 degrees?
It is 30 degree, but what is the sine of the 30 degree?
Oh, half?
1/2, correct. So the answer is minus 1/2. So the answer is minus 1/2. This is the answer of my question. So the answer of this question is minus 1/2. Okay, it's easy. Just use the steps. It's not that much hard. Use the steps, step by step. Find the sign of the function, then you have to find the reference. Just plug it. Use the reference and the sign. Then you have to use the table of the first of the section. I'm going to give you another example. Next step. Example. Find cosine of 240. Like this. Degree. The question like this in the exam. Find the cosine of 240. So first of all, you have to know what is the sign of the function cosine. What's the sign? Is it positive or negative? Depending in the angle, 240. So 240, so first of all, you have to know this angle is 0. This angle is 90. This angle is 180. And the angle here is 270. And again, we'll go back to 360. So 0, 90, 180, 270, 360. And you should to know the initial side must be in the positive x-axis. This is my initial side, positive x-axis. Now, my terminal side, it's 240. The angle is 240, is between 180 and 270. So this is mean the angle must be here, like this. So this is my angle, theta. Okay. So the cosine in the third quadrant, what is the sign of this cosine function? Number 1, the sign of the cosine function. What's the sign of the cosine function in the third quadrant? Go back. The only function in the third quadrant is positive is tan, and anything else is negative. So the cosine would be negative. Yes, Sandra, negative, correct. So here's negative. This is the first step. Second step, you have to find the reference angle. If the reference angle does not giving in the table like this and is hard to find it, you have to know the step like here. You have to use this way. The reference angle is the angle between, it's acute angle first of all, it's angle between the terminal side and the x-axis. So this is my terminal side. This is my x-axis first of all. And the green one is my terminal side. The green arrow, it's my terminal side. So my reference angle is an angle between the x-axis and the terminal side. So here, this is my reference angle. So what's the value of my reference angle? So as I know, the angle from 0 to here is 240. From here to this point is 240. And also I know from this point to this point is 180. Again, the angle from this point here to this point is 240. All of this is 240. And the angle from this point to this point, only the straight line is 180. So what is the angle, the reference angle, the blue one? What's the value for the reference angle? Equal what? $45, correct. Let me, you sure with 45? I think it's 45, but is it surely 45? From this point to this point is 240, and from this point to this point is 180. I think it's more than 45. This angle is between 180 and 240. So it's supposed to be what? 240 minus 180. What does that equal? 60. So the angle is 60, exactly. So this reference angle is 60 degrees. Because from this point here, all of this, I mean, all of this is 240, and from here to here is 180. So the difference should be 60. So it is 60 degrees. So I find the sign and also I find the value. So you can rewrite the cosine, the question as cosine of 240. This is equal. First of all, you have to put the minus. Don't forget the minus or the sign. It depends. It's minus or positive, whatever is it. And you have to rewrite the cosine as cosine. Now inside here, you have to put the reference angle, 60. This is the reference angle. This is the sine. Now, what's the cosine of 60? From the table in the beginning of this lecture. What's the cosine of 60? The cosine of 60. The cosine of 60 is 1/2, correct. So the answer is minus 1/2. So this is the answer of my question. So the cosine of 60 is minus 1/2. Okay, so I'm going to give you exercise. For some angles, and you should to practice for these angles to understand what actually we are doing. So the first one is find the secant for the angle minus pi over 4. And for the second one, find the sine. This is a very hard questions for 16 pi over 3. So for the first one, let me give you a hint. The angle here is negative pi over 4. First of all, the secant. The secant, it's the reciprocal of, for which function? The secant.
Cosine.
Cosine. So this is actually equal 1 over cosine, 1 over cosine of minus pi over 4. And the minus, what's the meaning of minus inside? When you see the minus inside, this is mean we have to move for the circle. How is the rotation should be? Counterclockwise or clockwise? If it's
Clockwise.
mine, exactly clockwise. So we have to move clockwise from my initial side. So this is my initial side. So this is my initial side. Here's my initial side. Here's my initial side. And we have to move clockwise pi over 4. Pi over 4 is smaller than, it's like in this quadrant. Like it's smaller than pi over 2. Pi over 2 is 90 degree. So this is the pi over 2, but it should be less than this, less than this. So it's supposed to be here. So the angle pi over 4 supposed to be in this quadrant here, like this. The minus mean the rotation, clockwise or counterclockwise. So the angle here, so this is the angle. This is the angle. This is minus pi over 4. Now, you have to find the sine of the cosine function in this quadrant, and you should to know what's the reference angle of pi over 4. So the reference angle of this angle pi over 4, as we see here in the graph, it's the acute angle between the x-axis and the terminal side. The reference angle is pi over 4. The reference angle here, as I see in my eye, it is pi over 4. And the sine of the cosine function in the fourth quadrant is, let me check, the cosine function in the fourth quadrant is positive. So the function here must be positive, first of all. Second thing is the reference angle is pi over 4. So this is actually, if you want to solve it, you should know The cosine function has a positive. It is positive. Cosine, the reference angle is pi over 4. Why? Because the acute angle between the terminal side and the x-axis is pi over 4. So cosine pi over 4. And what is the sign of the cosine of pi over 4? You should to know. What's the cosine of pi over 4?
Square root of 2.
Square root of 2 over 2, right? Like
Yes.
this. And this is equal 2 over square root of 2. This is the answer. Can you go back? Yes, where exactly? In which slide you need to go back? This slide here, Layla? Yeah, this is the cosine. The cosine function in the fourth quadrant is positive. So the cosine function is positive and the reciprocal of the cosine is positive. The reciprocal of the cosine is secant. Okay, so we're going to stop up to here today, and I'll see you in the campus on Wednesday for the exam. And all the details for the exam will be in the blackboard. Okay.